Okay, so this is the last slide that we saw in class. So I just want to put this back up just to make sure that you remember it and you see it one more time before tomorrow. So end behavior just talks about the function as it continues. So it's sort of like as you see these arrows that are going to typically infinity in one direction or another, we just talk about what kind of infinity they're heading toward. So in this case, this one says as x heads towards positive infinity. So as x is going to the right in a positive direction, as it goes to the right, is it going up or down? And in this case, it's going to the right and up. So we would say x is going toward positive infinity because that's to the right on our coordinate plane. So as x goes towards that positive infinity, y also goes toward positive infinity. And the same thing happens down here. Now, as x is heading toward negative infinity, so as the function is heading to the left infinitely, what's happening up or down? And in this case, it's going down toward negative infinity. So as x is approaching negative infinity, y is also approaching negative infinity. Okay, so let's do an example here with a function that we can make these little observations on our own. So this is the function. They draw it for us, and then they give us the actual value. So this is, if you graphed this function, you would put this input in, or this function, y equals negative x cubed plus 3x squared, would give you this function on graph. So our job is to then describe the various characteristics of a function, which is what this section is. So first, it asks us to describe when the function is positive. And remember, that's when it's above the x-axis. So this function is above the x-axis from everywhere. So above the x-axis here, this whole part is above the x-axis, right? Then it hits 0, so we can't count that. This is also all above the x-axis. Would you agree? So what we can say is that, I'm going to erase these first so that I can write it and not erase it. Okay, so it is positive. The function is positive from when x is less than 0, because that indicates this part of the function, right? Everything from here, this is all less than 0. We can't include 0 in this because 0 is not positive or negative, so that's not part of a positive or a negative. When it hits the origin, it's neither positive nor negative. Okay, then we can also say that it's positive between 0 and 3. So that's 3 right here is where it dips below the x-axis and becomes negative. So we can also say that between 0 and 3, so x is less than, 0 less than or equal to x, less than or equal to 3, indicates this second section of the function that is positive above the x-axis. We use the or equal to here because it is a line, and anytime we have a line, that's an or equal to because it's passing through the point and it's counted. So that's where the function is positive. Now, where it's negative is going to be this part below the x-axis. So going down to negative infinity, this is where the function is negative. And it starts getting negative along the x-axis when it crosses 3, right? 1, 2, 3. So we can say that it is negative when x is greater than 3. X is greater than 3. You know what? I need to backtrack here. These are not or equal to's because when it's at that point, when it's crossing the axis, we can't sort of include that point because it's neither positive nor negative when it's right at the axis. So we're going to always just use greater than or less thans for these when we're describing positive, negative, increasing, decreasing. Okay, so that's positive and negative. Then they want us to indicate when the function is increasing. So remember, this is where the function is going up. So it's rising from left to right. So increasing, it's only increasing along one section of the function. So from 0, from here, to this point here, which is at 2, we can say that the function is increasing between 0 and 2. Between 0 and 2. Okay? So if that's where it's increasing, then it's decreasing everywhere that it's falling from left to right. So from this negative infinity to 0, it's falling. And then it also starts falling again from 2 onward down to, infinity. So how we would write this is that, notice, it is everything to the left of 0, right? So when x is less than 0, the function is decreasing. So we would say it's decreasing when x is less than 0. And it's also decreasing when x is greater than 2. And so the points that I'm using here, where we're finding all of this is the origin, right? 0, 0. That's an important point. We call that an inflection point because it's where it changes direction, basically. The other important point here is, what is this, 2, 7. And those 2 points help us figure out where the function is increasing and decreasing. The x-axis helps us figure out where the function is positive and negative. The last thing it's going to ask us is about end behavior. Oops, I want to go back. End behavior. Okay, so end behavior is going to ask us to sort of state it in this way. As x approaches infinity. And as x approaches infinity basically means, what is the end behavior of the right side of the function? So as x is approaching infinity, what is happening with our function? Where is it headed? Well, it's headed down, right? It's headed down, and this is on the y-axis toward negative infinity. So in this one, as x approaches positive infinity, our y is approaching negative infinity. And then we also need to describe the end behavior for the other end of the function up here. Okay, in this one, our x is approaching, negative infinity. So as, you always describe as x approaches infinity, and then as x approaches negative infinity. So in this case, as x is approaching negative infinity, which way is our function going? Well, it's going up. It's going up toward positive infinity, so y is approaching positive infinity. Okay, and then the last thing is just a word problem. So let's look at this. It says, researchers send 2 robots to explore an asteroid. The graph shows the path of robot A. So they give you a graph, and this is robot A. The x-axis represents the distance in feet that the robot travels, and the y-axis represents the height in feet that the robot goes. And then here's the path of the robot. So again, this is my drawing, not taken directly from the book, so it's not perfect, but you can imagine what's happening here. So think about this. This is the path of a robot. A couple important things to think about. Okay, the distance of the robot started here, right, at 0. And then it goes up. Think about this. This is height. So it's going up. And then it falls and it lands kind of right in between 40 and 60. So probably somewhere it lands about 50 feet away from where it started. And think about this. This is right here would be the maximum height that this robot reached, right? Because it's going probably almost 60 feet in the air right here. And it hits that maximum height when it's about 30 feet away from where it started. So if we were going to call this a point, this is at 30, 60-ish, right? Not exact, but so there's robot A. Let's see what they ask us about this. Then it says robot B lands 60 feet out and reaches a maximum height of 48 feet after traveling horizontally 30 feet. So let's sort of sketch. Clearly it won't be perfect because my graphs are not perfect. It says robot B lands 60 feet out. So robot B is going to land out here, right, at 60 feet. And it's going to reach its max height of 48 feet. So it only goes about this high, right? About 48 feet, a little bit below 50. After traveling 30 feet. So it's still going to reach its max height at the same point, the same distance out. And then if we sort of sketch the path of robot B, that's what it would look like. Here's what the question asks. Graph robot B, compare. Well, here's our comparison. So when you compare, probably on homework, it's going to give you a drop down, but being able to sort of describe what's happening with robot B, it goes farther horizontally, right? Because it lands way out here. It also goes lower in terms of its height. So it doesn't reach the height, the purple one, robot B, does not reach the height that robot A reached. It's a lower arc, but it goes horizontally farther. So if we're going to compare those two, that's what we would say. And I think that's all that they're going to want you to do. So that is all, you guys. Tomorrow the homework is going to be to be able to identify these things. So what are the x-intercepts? What are the y-intercepts? Where is the function increasing and decreasing? Where is it positive? Where is it negative? And then describe the end behavior. So these are just important things to be able to talk about with functions because they help us describe what kind of a function we have. And they give us a lot of information about how functions behave in general. So anyway, that's it. Take good notes. Use these tomorrow on your homework. See you later.